Now, let us start with the next topic of the chapter solutions, that is ideal and non-ideal solutions. Let us first talk about ideal solution. Ideal solution is that which obeys Raoult's law over the entire range of concentration. In these solutions, delta H mixing will be 0, means whenever you mix the components, there will be no loss or gain of heat. Similarly, there will be no change in the volume too. In such solutions, solute-solvent interactions are always equal to those of solute-solute and solvent-solvent interactions. Perfectly ideal solution is rare, but some solutions have nearly ideal behavior. For example, solution of N-hexane and N-heptane. Now, intermolecular forces between hexane-hexane are London forces, as the molecules are nonpolar. Similarly, the intermolecular forces between heptane-heptane, those are also London forces. And the interactions between hexane and heptane, they are also London. So here you can see that solute-solvent interactions are same. Then, non-ideal solutions. These are those solutions which do not obey Raoult's law over the entire range of concentrations. In these solutions, there will definitely be loss or gain of energy. Similarly, there may be a change in volume also. These are the solutions where solute-solvent interactions are not equal to that of solute-solute and solvent-solvent interactions. Not equal means either they are greater or they are lower. If solute-solvent interactions are greater than solute-solute and solvent-solvent interactions, greater interaction means less vapors will be formed. So in this case, vapor pressure of the solution will be less. This is called negative deviation from Raoult's law. Example, chloroform acetone. Now, if solute-solvent interactions are lower, interactions lower means more vapors will be formed. So, vapor pressure of the solution will be more, and this is called positive deviation from Raoult's law. Example, acetone and carbon disulfide. You can see graphically. This first graph we have already done, we had already seen when we were doing the Raoult's law, that corresponds with the ideal solution. This we had already discussed. If you see the graph A here, the blue line represents the vapor pressure of the solution. You can see the blue line of the solution is much greater than green line of the solution. So here the vapor pressure is more. This is called positive deviation. Example, as we have discussed earlier, it is ethanol water. Now ethanol molecules have got hydrogen bonding. Water, but when you add water to ethanol, some of the hydrogen bonding will be broken. Interactions less means more vapor pressure is being. Now in graph B you can see, in graph B, the blue line vapor pressure of the solution is lower than the green line. Here, example is also shown here, acetone and chloroform. When you mix the two components, hydrogen bonds are being formed. Hydrogen bonds are stronger among intermolecular forces. So more forces means less vapors. So that's why vapor pressure of the solution is on the lower side. So this is called negative deviation from Raoult's law. Now students, you must practice making these diagrams very carefully in your copies. The diagrams must be completely labeled and correctly labeled. Now, azeotropes. Some liquids are mixing from azeotropes. Azeotropes you can give three-word definition as constant boiling mixtures. Constant boiling mixture. These are the binary mixtures which have the same composition in liquid and vapor phase and boil at a constant temperature. You cannot separate the components of azeotropes by fractional distillation. Now in the previous slide we have seen positive and negative deviations from Raoult's law. In positive deviation, what was there? Vapor pressure was more. So that mixture will boil at a minimum temperature, means that will form minimum boiling azeotrope. Minimum boiling azeotrope. Example was same, ethanol water mixture. On fractional distillation, it gives a solution containing approximately 95% by volume of ethanol. Means you cannot separate ethanol and water by fractional distillation. Then, from the graph of negative deviation, what we have seen that vapor pressure has decreased. So, the boiling point will definitely increase. So, it will give rise to maximum boiling azeotrope. Example, nitric acid and water mixture. 68% nitric acid and 32% water by mass. They will also boil at a constant temperature of 393.5 Kelvin. You will not be able to separate nitric acid and water by fractional distillation. Now here are some questions for you. I want you to write the answers to these questions. Students, all these questions I have taken from the previous year board papers. So it is very important that you write the answers of these questions in the copy, and we'll definitely discuss these questions whenever we'll meet in the class. Thank you.